Okay, so today we will be looking at the root pavement, okay, which is an important topic in our course. So the content of this lecture will be the pavement, why and what is the pavement and why we are using the pavement, what are the pavement materials, what is the classification of pavement, what are the factors that affect the pavement design, and what are the methods of uh, design of pavement, empirical method and mechanistic method, and pavement defects. Okay, these are some challenges has that have been arised in Australia. So the problem in the routes in Australia is that there is a very big and wide country, so we have long distance routes, dry condition due to the arid weather, low funding for routes, and low traffic on rural routes. This makes the roads maintenance and road design sometimes challenging in Australia. And if we look at the roads in Australia, the roads in Australia was almost 900,000 kilometers or almost 1 million kilometers. 70 of this 20% of these roads are in rural areas and only 30% in the urban areas. However, both the both the rural and urban networks need to be maintained and improved to connect the farms and the towns to transfer the goods and transfer the vegetables and so on. So that's why controlling this length of routes is a bit challenging in Israel. Okay, and if we compare the routes or the length of routes per capita here and in other countries, so in USA, in USA, like we have 280 meter per capita or per person, which is the length of routes per person. In Japan, it is almost 130 per capita. In UK, 90 meter per capita. And in Australia, it is 450 meter per capita. So as you can see, due to the low population in Australia, so it's almost 450 meter per capita in Australia. Okay, so this is just comparison between the route lengths in USA, sorry, in Australia and other countries like USA and Japan and UK. Okay, so now, why we need roads or pavement? The roads are very important in safety because the routes define the way you are going, so you know the way. So, for example, if you are heading in the desert or something, so you don't know where to go, but with the route you know where to direct and to safely arrive to your destination. The routes are dust-free surfaces, or the pavement make the routes the dust-free surfaces. And also one of the important safety condition is skid resistance. So when you need to stop, you stop safely, like braking. Okay. Also, one of the important advantage of the pavement is the comfort. So it's easy to ride on the pavements. The cost, because the pavement will reduce the operating and maintenance cost for the vehicles. So because it was less damage compared to the unbound roads. And finally, the support and drainage. Support distributes wheel loads to reduce the soil pressure. So the pavement will distribute the forces or stresses from the vehicles or from the traffic so that reduce the stress on the soil. And also drainage minimize soil softening. So for example, if we have some root, as you see here, this is maybe our root. It has some inclination to so that the water, when the water comes, the water goes to the shoulders, and sometimes we have some like channels to collect the water here. So when the rain comes on the root, when the rain comes to the root, this water will go to like for drainage. This water will go to this channel, and this will minimize the soil softening and keep the soil strong. Okay, so this one also of the advantage of the pavement. So this is our pavement. Okay, so now we jump to the types of pavement. The types of pavement depends on how the load of the vehicles or the load of the traffic distributed to the soil. So we have two types, flexible pavement or rigid pavement. Flexible pavement, is the one on the left here. This is flexible pavement, which include, for example, the asphalt pavement. And rigid pavement is the photo on the right here, which is, for example, concrete pavement. And what is the difference between the flexible pavement and the rigid pavement? The flexible pavement is flexible, so as you can see, if this is the wheel, and this is the wheel load. So the pavement is flexible, working flexibly. So as you can see, here is the stress or the deformation of this layer can be only under very small area under the wheel. Okay, so this is called, like, for example, yeah. So the area of distribution of the stress is very small. So that's why it's called flexible pavement. Okay, but if we look at the rigid pavement, so if we have again, this is our wheel load and this is the wheel. So as you can see here, this, the pavement is very rigid. So very rigid means very strong. Okay, so this is our wheel load and this is the wheel. So as you can see, the the pavement transfers the stress on a wider area or wide area. Here, narrow area of stress distribution. Okay, because so when the load is applied to the pavement, this what happened to the root, to the pavement. So this is rigid pavement because it distributes the root over wider area. So this is the differences of the two types we have of pavements. And Let's talk about start with the flexible pavement to see in depth how the stresses are transferred. Okay, so for flexible pavement, we have again the asphalt pavement. This is the most important uh, type of pavement, or the most common one. And the design life of this type is a bit short, from 20 to 30 years. Okay, and one of the advantages is easy to repair, especially in urban areas. Okay, because as you know, in urban areas, we have a lot of like utilities and like the bikes and so on. So you need to have like uh, easy way to cut in the pavement to like fix the or install the like water pipes or electricity pipe and so on. So the flexible pavement provides this advantage compared to the other rigid pavement. If we look here to the figure here on the left, so as you can see, we have like four wheels of a car. So this is called axle of the car, and we have two tires in each one. So this is just an explanation of the tires. Good. Okay. If this axle is totally 8 kilonewton, and this means that each wheel will transfer like 20 kilonewton, which means almost 2 ton to the root. So how this load or this stress transfer? So as you can see, these are the layers of the pavement. You can have surface course, base course, sub-base course, subgrade course. So this can be the surface course, for example, in this type will be the asphalt layer. But let's talk about the layers later. But here, how the stress is transferred. So if you look here, the stress under the wheel was distributed over a very small area, and then the surface course will distributed over a wider area like this. Then from surface to base, the stress will be redistributed again. So in this layer, the stress can be like similar to the case we have now, or can be a different case. This one or two cases depend on the strength of the soil. Okay, and then the soil will keep redistributing the stress until reaching the subgrade, which is our soil. Okay, so this is how the stress. So the stress here under this point was very high stress, but now it is low stress. So this is the idea of the layers of the pavement. Okay, then now let's talk about the layers. The layers we have again surface course can be the asphalt layer, which usually thin layer, and then we have the base course layer, which usually from granular materials. And sub-base course also can be from granular materials or mixed with cement. So it can be granular, pure granular, or mixed with uh, cement. The subgrade, which is natural soil, but this natural soil need also to be prepared or compacted before constructing the road. Okay, so if you look at this hint here, the primary function of this pavement layer is to distribute the stress over a large enough area so that the subgrade can take it without failure. So all the idea is the stresses at this level, the stress at this level, if you remember from the design of footing, is less than the bearing capacity of the soil. So this is the idea behind the stress. Also, one of the hints you need to know is here the base course is carrying more stresses. If you can see here, the stress here is more than here. So the base course should be from good quality material. Okay, but sub base because it's carrying less stresses, so the sub base less stress, so it can be low quality material. So you don't need to like uh, spend a lot of money on the sub base course because it will not carry same stress as base course. So this was some explanation about how the stress transferred or distributed over the flexible pavement. Another type of flexible pavement, if you can see here, is called unbound granular pavement. So this is another technique, or called spray sealed routes. So the spray sealed route content of or consists sorry of this very thin layer, maximum 10 to 15 millimeter. Okay, and again we have the base course from granular material, the sub base course from granular material. Again, this high quality material, this low quality material. Okay, and this is like the we can have a look at the video here. So this is the truck like distributing the granular material, and then on top of that this is a sealed layer of bitumen. Okay, this can be sprayed. That's why this route is called spray sealed route. This route or this type of route is common in Australia and New Zealand because it is low cost route and provide reasonable performance. Okay, so just have a look on the video here. Okay, so this was the spray sealed technique in rules. So let's go to the next type of flexible pavement. So the third type of flexible pavement, as you can see, is called full depth asphalt. So full depth asphalt pavement. So here in this type, all the layers are from asphalt. This type of roads is high cost, but this is needed sometimes in the when you need very strong roads in highways, for example, which are very heavy loaded routes. So in some cases, when you need strong routes, you need to make all the layers from asphalt. For example, the top layer here, so the top layer, and the base course asphalt, the sub base course asphalt. So all the layers are from asphalt. Okay, and if you look at the cross section here, so you have this top layer from asphalt here. If you notice, just the because asphalt is mixed with granulars, so the granulars are small size, and when you go down, the granular materials with larger size. Okay, so this is another example of the flexible pavement, and let's jump to the Rigid pavements. So the rigid pavements are mainly concrete pavement, most common one. As you can see, the surface course is a bit thick layer compared to the other. Okay, this is a layer, at least 200 to 300 millimeter concrete. And again, we have a base course. This can be granular and subgrade. Okay. The advantage of the rigid pavement that again is the stresses is distributed over a wider area. Okay. So that's why we don't need too many layers because the stress already on wider area, so lower stresses on the subgrade. Okay, but also in some cases, as you can see here, any base course can be sub-layering. So for example, you can have another layer here. So this layer 1 and layer 2 is also possible. That depend on the design. Okay, so this can could be upper and lower course or lower base, upper base or lower base. Okay, so only in some cases if needed for design. Okay. Also, the lifetime for this pavement is from 40 to 50 years. This is advantage over the flexible pavement, and also it need less maintenance. But the problem is like very not very easy to for like if you remember for the flexible pavement I mentioned about the bias and electricity and so on. So here in this one is repairing or installing utility pipe is very hard or is a difficult job due to cutting in concrete. So concrete is very tough material, so it's hard to cut it. Okay, so here we have some example of roots, not common roots. So we have here the unbound macadam, and here the interlocking masonry. And if you search about this, or if you want to know what is the type of pavement these two are, so both of them are flexible pavement. Okay, this one can be this one as well can be used in driveways, and actually this is the name of the person who first do this or invented this type of route. Okay. Here, even this type, the interlock masonry, even this beaver is rigid, but they are working separately. That's why this type of pavement is flexible pavement, not rigid pavement. Okay, so these are some pictures of the two types of road, and here as well we have some asphalt pavement photos. As you can see here, we have the asphalt, and this is a cross section of asphalt. Okay, and here again is the spray sealed pavement. As you can see here, here is the granular material of the base course, and just this truck spraying the bituminous layer, which is only 10 to 15 millimeters. Okay, so this is very common in Australia and New Zealand. Okay, and here is the concrete rigid pavement. As you can see here, we have this machine or this grind machine, and this is the concrete, and this machine is finishing the concrete. And as you can see, the concrete pavement can have some reinforcement. Okay, these reinforcement are very important, especially at the joint, as you can see here in the left. So if you have, for example, if we have elevation two layers together, so we need to connect them with some steel dowels. Why these are important? Because if you have applied a wheel load here, somewhere here, so sometimes the wheels or this car will be only like moving on this slab, concrete slab. So this is concrete slab. So what happened when the load is very high here? So what happened is this layer will a bit deflect like that, okay, and leave this alone. But if we have the dowels, these dowels will distribute the load between the two pavement, the two slabs of pavement. Okay, so that's why these are the dowels we are talking about, and these dowels are very important. We have here as well, we might have here. So if this is our layer membrane or our slab, and this is another slab, and this is another slab, and so on. So these are important to distribute the forces between or the stresses between the adjacent layers or adjacent slabs. So now let's talk about the pavement materials. The pavement materials can be classified according to their behavior under the applied loads. Two, unbound granular materials and modified granular materials and cemented materials for asphalt 5 concrete. So these are the materials used in pavements. Okay. So if we look at the unground material, unbound granular material, as you can see in the figure here. So this is the unbound granular material, and here is the unbound granular material. These are well-graded crushed rocks or gravel, mechanically stable, workable, compactable. Okay, so these are compactable materials and well-graded crushed rocks. But the disadvantage of this material is doesn't have any tensile strength or doesn't have significant tensile strength. The construction consideration for this material is needs a high level of compaction, and to make it uniformly of placement. So to reach this one, we need like the rulers to compact it. Okay, so need high level of compaction. The next one is the modified granular material, which is unbound granular material but was modified using stabilizing agent. So small amount of stabilizing agent was added to the unbound material to improve stiffness and other soil properties. For example, reduce the plasticity of the material, but still doesn't increase the tensile capacity significantly. So the advantage of modified to unbound material is the stiffness and other soil properties such as the plasticity. They are considered to behave as unbound granular material. So this is also one important note here. So the modified and the modified granular material still considered as unbound granular material. So difficult to make sure no bonding occurring, often reworking needed. So and sometimes it is difficult to make sure that no bonding happen due to the agent. So this is due to the stabilizing agent, and the stabilizing agent is bitumen or lime or cement with a percent almost 2%. Okay, the problem is we don't in pavement we don't like the bond between granular materials because it is not very good under repeated load. Okay, so the problem of this modified granular material is the bond. Sometimes bond occur, so we need to make sure that bonding doesn't occur because the bonding will cause some problems in the pavement due to due to repeated load. Okay, so these are the modified granular material, and the next one is the cemented materials. The cemented materials consisting of binding agent, water, and granular material. And this binding agent can be Portland cement, blended cement, or lime, etc., etc. So we can have Portland cement and or blended cement or lime or slag. So all this can be the binding agent. So it's similar, quite similar to concrete, but different mixture in proportions. So the mixed and compacted in the early stages of hydration. So this need to be compacted before sitting, otherwise not be able to compact. Curing may be necessary because it contains cement. Cement is still react after sitting, so need to add some water to complete the reactions. Binder should be added in sufficient quantity, so the binder should be added with sufficient quantities to make sure it's bind to the granular materials. This one this is the advantage compared to the others material. The two previous material doesn't have significant tensile strength, but in this case we have significant tensile strength. So this one is the advantage we have compared to the previous two material. But the problem here is some problem we face in this type of material is, as you can see here, some damage can happen to the corners. Okay, but this can be overcome. And the next material we have is the asphalt. And as you know, asphalt is consists of bituminous binder, and several single sized aggregate fraction. So here as well we have the bitumen plus single sized aggregate. Okay, so we can have like similar size aggregate. Okay, so this is asphalt. Need to be spreaded and compacted while it is hot. And also this one is a disadvantage because the construction sometimes is affected by hot or cold weather. So you need to select the appropriate time to construct your roof. The binder in general conventional bitumen. So this is the conventional or the most common used one. May be modified by addition of specific polymers for special application. Sometimes can be modified by some polymers. The strength of the asphalt depend on friction between aggregate particles. So the friction between the particles will cause the higher strength or lower strength of this aggregate. So here the friction will will affect the strength, the viscosity of the binder under operating condition, like hot or cold weather, will affect the strength as well. The adhesion between the binder and the aggregate, so this is also one of the parameter. Finally, the concrete. The concrete, we have cement, fine aggregate, coarse aggregate. This is the main component, plus water for sure. Some additives can be added to achieve some desired properties. For example, fly ash, slag, and silica fume. The concrete can be used in surface, base, or sub-base layers. So the concrete can be used anywhere of layers. The properties of concrete may vary due to like mixture proportions, strength of aggregate, and water to cement ratio. A lot of parameters that affect the concrete properties. So depend on the application or what is the loads on the roof, this will affect the design of the concrete. Okay, and that's it for the first part of our lecture. The design and the next the topic is our design factors for traffic. Okay, so Dylan, are you okay to have like 5 minutes break? Okay, thank you. So see you after 5 minutes.